Cloudflare recently launched Hyperdrive, which provides efficient pooling and fast queries for any MySQL or Postgres database. And since PlanetScale offers the benchmarked fastest Postgres offering, it just makes sense to pair it with some of the fastest cloud services. Once you're inside of Cloudflare's network, you have access to all of their other services, things like durable objects and WebSockets, which I've used in this demo application to power a real-time experience. And one note before we continue, in a lot of coding videos, you'll see code examples on the screen. I'm not going to get into the fine details of how to set these things up because I'm anticipating that, like me, you'll be using an LLM to do most of this implementation. I just want to show you the decisions I made, the decisions I didn't, and the infrastructure I've chosen to build this really great experience. So what is Cloudflare Hyperdrive? If you'd like a raw comparison between a traditional Postgres connection and a Hyperdrive connection to see the speed improvements that you'll get, there's a great video on the Cloudflare Developers YouTube channel, which you definitely should check out. But here I just want to whiteboard for a moment what a typical setup looks like versus what a Hyperdrive connection can look like in simplified terms. So our typical application is like this. We get a very fast connection between our database and our application if we put them very close together. And that's a really good common sense setup. What we have though always is a handshake between our application and our user. And there's really no getting around the physical limitations of if your database and your application are very far from your user. And this handshake can be multiple hops in between that needs to be connected. And there's also the issue of disconnecting connections and pooling them and making sure that our cache responses are up to date and so that user is getting valid information as fast as possible. There's a lot in this handshake connection here. And that's what Hyperdrive aims to make very simple to do with almost no config. So if instead of the application being very close to the database, we move it very close to the user, and we actually can sort of reduce the US East 1 size here. And we say that, well, Cloudflare has this thing called the global network, and that's what it's going to distribute the application around. So it doesn't matter where this user is or any other user is, they'll be all around the world, and the application will be distributed all around the world as well. So within many connection points, and you'll see this in a moment, we can distribute the application on the Workers platform. So what we can then do is have a pool of connections very close to the database. So it won't be within US East 1, but it will be on Cloudflare's own network, which has an incredibly fast connection to US East 1. So we can call this the Hyperdrive pool, and this will be automatically connected. This will take care of connections, disconnections, and all of that. And so any transport between our database and our application happens over Cloudflare's network. So it's incredibly fast, it's cached, it's all of that. And this connection here is very fast as well. Can we get that arrow? There we go, pointing into there. So this is transport happening within Cloudflare's own network, which is incredibly fast. Additionally, there is an extra option. If your application makes a lot of sequential writes, that is like a write that depends on the results of a previous write, you may have better time moving your application once again closer to your database, or at least closer to that connection pool, and putting that latency back here. It's not the case in my application, but it is worth considering. So this is one of those trade-offs, it depends situations, but something to consider. You can either have your application very close to the user or very close to the database, and whatever your application does may improve based on that location. If you're new to working with Cloudflare's infrastructure, you'll come to learn that there's a lot of names for a lot of things, and that can be initially confusing. So I'm just going to unpack the ones that I used in this particular application. So the Cloudflare Global Network is sort of the backbone of everything, and it is this very fast transport all across the world for your data with so many connection points around the world. So it says here that you'll reach about 95% of the world's population within approximately 50 milliseconds. So putting your application on that network serves very fast responses to your end users, but also means that data transported across the network is incredibly quick as well. And so Cloudflare Hyperdrive is what we're using for our database connection between PlanetScale and our application. And I've already just covered that in the previous section, but we could see the documentation there for more. Cloudflare Workers is where we're going to host our application. It can host applications of many different framework choices and put it all around the world on the Cloudflare Global Network. And durable objects have a funny name, but they are a stateful, single origin place where you can run logic. And so we're going to use it in this application to be the place where we send out our WebSocket updates to anybody who is currently connected to the application. And WebSocket connections are something that Cloudflare supports as well. So that's what we're going to use to send real-time updates to every connected user. So that's all of my infrastructure choices. And when it comes to my front-end framework, I'm just not sure that that matters as much as it used to. But I think a really great starting point for an application is to use a template, not try and start an application with an LLM whole cloth. And fortunately, Cloudflare does provide us a Workers-compatible template to start a new React Router application. And this snippet here is exactly where I started with my app. So I'm using PlanetScale Postgres Metal for my database and my source of truth. I'm using Cloudflare's infrastructure to host my application and handle all of the database connections. I'm using React Router 7 for my front-end framework. But I've got all those other bits I just talked about, so we better go back and diagram how those work, because if we put them together wrong, we might actually introduce a worse experience instead of a better one. So here within Cloudflare's global network, that's what the circle's supposed to be. It's like the Earth. I'm going to use a durable object for my webhooks. So here we're going to say that our durable object lives up here. And so this is this single origin, stateful place to run some logic. Now, what I want to do is have the application make a write to my database. And when the response comes back, my worker is then going to signal something to the durable object, which is then going to say, okay, send out a webhook to let that application know. But not only that application, let every application know. So say we'll introduce our other user again and the application that they are connected to. We can make sure that our durable object will send that signal there as well. Getting a bit convoluted. Maybe I should have used smaller shapes, but I think you know what I mean. Now, if we're going to make sure that the application writes back to the durable object, this introduces one of those questions. How should I do this? Perhaps instead of writing to the application, if the durable object is in charge of sending out updates across the network, maybe we should do our database writes in the durable object instead. So what if instead of our application handling reads and writes, the durable object could be that single source of truth as well? And this is what I tried initially, was to say, actually, let's do all of this connection up here to this durable object, because then that's going to be that single source of truth. It's going to handle everything. It's going to know when writes are finished. It's going to fan out those responses to everybody over webhooks. But this is actually really problematic. The point of using the Cloudflare global network is that this work is going to be distributed everywhere. So every worker can talk directly to the database. If we send them all through the durable object, well, this is single-threaded, and now this is not just a single source of truth. It's actually a bottleneck. So this was a really bad idea, and I'm glad I pulled this back out, because it seemed like a good idea at first until I sort of figured out how this would be best done. So it doesn't depend on the user's network connection. This is important too. The worker, if it has received a notification of a successful write to the database, it is going to send off a signal to our durable object. And then the durable object is going to send out WebSockets to every connected user. So this is a system that works, and it's worth caveating this with there's many different ways to do real-time databases. And what I'm doing here is trying to do this all within Cloudflare. There are other services. We could also add extra reliability to this, and I'll get into some of the trade-offs later, but this is a system that works, and so let's build off of this infrastructure for now. Okay, great. You made all those infrastructure choices. Tell us what you're actually building. So I'm building a prediction market in my demo application here. And the reason I've chosen that model is because I need really fast reads, really fast writes, and real-time updates. That's because it's not like an e-commerce store where you're buying fixed products for a fixed price. Every transaction can change the price for the next person. So it's really important that everybody gets the up-to-date price at every second new prices come in and as transactions are logged. So I've got a transaction log over to the side here. I've got real-time updates through my WebSockets, and I've got what the current price of buying an option on this market is. So I'm going to spend 10 tokens buying a yes option here with a 55% chance that I'll get 18 tokens in response. And so you can see immediately I get an update straight away here because I've bought that. The percentage odds have now changed. My transaction has added into the log here. And those are the real-time updates that I want to make sure that every user can get. So this is quite simple, really, when it comes to database-driven applications. I'm sending writes and I'm receiving responses. But it's one thing for me to get that response immediately. Once my worker gets that response, that's when it's sending a signal up to the durable object to send a WebSocket notification to everybody else who is currently connected. And it's one thing for me to just spam on the yes button here and do a bunch of transactions. We can see here one of the trades wasn't executed. It might have been that the price was stale by the time it was sent. And this is also part of the challenge of this model, is I want to make sure that the price is accurate in the browser, but it also has to satisfy the price in the database as well. We don't want people to be able to buy things at a different price because it was displayed that way in their browser, nor do we want people to be accidentally oversold something at a different price to what they expected. So the price is actually maintained by the database itself, but we are sending updates as fast as possible to make sure that users cannot buy things at the wrong price. So that's the requirements and the use case of my application. How did we set up that connection between PlanetScale and Cloudflare? Well, it's actually quite simple. In the PlanetScale dashboard here, I can go and create a new database. And here I'm going to give my database a name. And for this project, I'm going to choose the PlanetScale Metal database, which starts at $50, but I could have chosen the non-metal $5 Postgres starter as well, just to get this proof of concept going. So now I'll create my database. We'll give it a few moments, and then our database looks like this. Once it's spun up, I've got a primary and 2 replicas, and all I need to do is go and connect to that database. When we click connect, I can choose the default role, but that's really only recommended for, doing schema changes, DDLs, that sort of thing. I'm going to use a user-defined role here, and my application really only needs to read and write data, so that's what I'm going to give it permissions to do. And so from this connection page, which includes these passwords, which I've already wiped by the time I've published this video, we can choose which connection we want to add to. And there's lots of starter templates here for different frameworks. But the great thing about our Cloudflare connection is it's already automated with my own personal login, and I can go and create a Hyperdrive configuration on the Cloudflare dashboard. And then immediately that's set up our Hyperdrive connection, and it's as simple as copying this string here, the ID string, into our Wrangler config file in our project. Keep in mind too, you do have the option of using a local connection string to just use like a Postgres database on your own computer for local development, because writes over Hyperdrive from your own local computer outside of the Cloudflare Workers network will be a bit slower. So that local development experience isn't great over Hyperdrive, but it can be improved by using a local database. Either way, it's up to you. Something else I would strongly recommend you do before you move too far along in your project is actually to set up a separate branch. So when you're vibe coding and you're just getting a proof of concept going very quickly, operating directly on the main branch is probably a great idea. But what would be better is to set up a separate branch for things like staging or development, so that you are never touching production data. And what you could do then is repeat the same steps again, is go through the connection page, create another Cloudflare connection to be able to deploy different databases to different workers' hosts. So now I've got that connection string between Hyperdrive and PlanetScale, and I've also prompted into existence that durable object with our WebSockets connection. So every time a worker receives confirmation of a successful trade, it then sends signal to the durable object to send out a WebSocket to every connected browser. So when I look at my application like this, I've got it in 2 tabs open at the same time. This trade ledger on the right-hand side should be updated in real time, as well as this market graph on the right-hand side. And so if I make a purchase in one browser, it should be updated in both. And what we're seeing is incredibly fast. Obviously, not the same as if we were able to simulate testing from all around the world, but very fast for our use case here, which is great. Now, admittedly, this is quite a primitive real-time setup at the moment. We could have gone deeper, but this is just a demo application. We could have implemented polling so that on a regular interval, we also checked if there were any transactions that were missed by our real-time updates. I could have added queues, and Cloudflare has queuing as well, to say that transactions should actually go into a queue and execute in order instead of just every transaction being written to the database as fast as possible. And WebSocket connections can drop and need to reconnect. You could add some extra logic there to say, when we reconnect to a WebSocket, go and check that we have all the latest updates as well. The point is that adding any of those things wouldn't require us to move platform or migrate away later. I've got a very good proof of concept now on this infrastructure, and I can make it even better as the app continues to grow. And so to test my application with a bit more scale, I created a seed script which put up 100,000 transactions, 20 users, a whole bunch of markets, and a back-end dashboard interface where I can hit start trading and start sending transactions through every few milliseconds. And we're seeing those transactions go through on the trade ledger on the left-hand side, and those markets are making subtle shifts in prices as those transactions come through. So our application has a great backbone and it clearly works the way we want it to, but as our application grows, how do we keep an eye on what could be improved from here? Well, the dashboard has our insights from PlanetScale, and these have always been a really popular way to navigate through the health of your database, the health of your application, and the sorts of queries that are being performed. You will see I've got some really nasty P95 and even a P99 spike there. That's happening from that simulated traffic that I was sending earlier. It's not good. I have been admittedly over-relying on Hyperdrive's efficiency for performance, and I haven't really done a single thing to try and optimize these queries that are going to my database. They've all been vibe coded, but that's what Insights exists for. And typically, once upon a time, I would have to have gone and inspected this query. I could hit summarize query here and find out what that query is doing, and then go into my application code, try and find that and fix it. Fortunately, the PlanetScale MCP server can really handle a lot of this for us. So over here in Cursor, I've got a prompt already to go here saying use the PlanetScale MCP server to look up our current P95, P99 queries on the staging database, the main branch, and consider how we can optimize those queries. I can send that prompt away and it'll start to do that investigation for itself and compare the queries that are showing up higher in Insights there with the queries that are being performed in my application, find the issues, and then start to work on suggesting alternative fixes. Another way to stay proactive instead of reactive with Query Insights is to use our database skills package, which will help guide your LLM to make good decisions about data structures and data models and queries. And if your application's a runaway success and you've done all the optimizations that you can possibly do, you might still need to update your cluster size. And that's easily done from the PlanetScale dashboard as well. I can go here to clusters, choose a different cluster size there. And that's it. A quick look at how easy it is to connect Cloudflare and PlanetScale together through Hyperdrive, get all of those performance gains from Hyperdrive's single connection string, and then start exploring some other parts of the Cloudflare network to add more functionality to your application. If you found this useful, let me know. Or what other challenges do you have in your application when it comes to optimizing the way it works with your database? Let us know in the comments below.